Hello people, today we're doing the same problem in JavaScript as we did the last episode in C Sharp. So let's go very quickly with, since we already explained the theory, what is a palindrome? A palindrome number is reading from left to right the same as it reads from right to left. So 1 to 1 is a palindrome because from left to right we get 1 to 1 and from right to left we get 1 to 1 as well. Every negative number is not a palindrome because from left we have minus 1, 2, 1, and from right to left we have 1, 2, 1, minus. So we have this, which is not the same string as this one. Now, there was this mathematical way that we can do, but the reason that I'm going with strings is because it's more natural, and today we're doing just that. We're doing the string version in JavaScript. Now, the first thing that I want to do is to create two strings, string 1 and string 2, and then I'm going to compare them. I'm going to build the second string and I'm going to compare the first one to the second. It's always nice to write comments about how you're going to proceed. So let's create two strings. Then we're going to build the second string and then we're going to compare the two strings. All right, so that is the way we are going to proceed. And create two strings, build the second string, and then compare the two strings. Okay, good. If they're equal, it's a palindrome. Oh yeah, by the way, how are we going to build? That's important. So I'm going to take the last digit of x and append it to the beginning of the first string. Okay, so that is how until no more digits left. That is legit. And then we're going to compare them because the second string is going to build from backwards, from the back number. So let's go with the comments and we're going to decide if we need something on the fly. So creating two strings, I'm going to say const first string, first number to string is going to be equal to our x, so our own variable that we get here, because this one I want it to be const. I want to store the variable somewhere since we're going to do some iterations on it. And it's always nice to have like local caching, and that point should be here. Now I'm going to create the second string. The second string is going to be something that it's not going to be constant, so I'm just going to say let second number to string is going to be equal to an empty string. Okay, so that's pretty much it. Now we need to build the second string and then we need to compare them because now they're obviously not going to be equal. The way I'm going to do that is I'm going to say while x is larger or equal than 1 to 1, I'm going to make this iteration. Now I want to take the last digit of x, and the way you can do that is when you have, mathematically, when you have a number like 1 to 1, if I say modulus 10, I'm going to get the last digit here. Because if this is 0, it means that I'm going to divide 10 without any number left, meaning that I'm going to get 0. If this is 3, I'm going to divide this without anything left, but I'm going to have a 3 left because I cannot do the 3 divided by 10 without having a point. So that's the way I'm going to do it. In order for me to do that, first I need to say let current number to string, or I'm going to say actually, to keep it a bit more consistent, current digit, because this is actually the last digit that we're going to get, is going to be equal to our x modulus 10. Now, this is going to give us a problem because we're having the floating point, and I actually need to say math.round that, and then make it to a string, just so I can append it to the second number to string. So now we have the last digit here on the current digit to string, and we are rounding it. Yeah, okay. And I'm going to say second number to string plus equal current digit to string. Good. So the final thing that's left for me to do is to actually divide by 10. And lastly, I'm going to get out of the loop, since I'm going to divide by 10 here, divide by 10 here again, divide by 10 here again. and when I get to 0 point something, I'm going to exit the loop, and I'm just going to compare the two strings. So I'm going to say first number to string equals second number to string. If it's a palindrome, this is going to return true. If it's not, it's going to return false. Now, there are a couple of problems with this solution. And the first one is that what is going to happen if I get a 0? Because here I enter the while loop only when I say that I'm bigger or equal than 1. If I'm a 0, I'm not going to enter it. So I'm just going to check for this case. It's going to be an edge case, so I'm not going to bother. If it's a 0, it needs to return true because it's a 1-digit number, meaning that I am a palindrome definitely because I have only 1 digit. So if I have the digit 1 to 9, everything is considered to be a palindrome, since 9 from left to right is read 9 and from right to left is read the same way. Okay, and now there is this problem here that I'm going to show you. Console log, I'm going to say current digit to string, and I'm going to run this. I don't know if we're going to get the proper result, but I'm going to, oh yeah, we don't. So you can see 99999 here. Now the problem with that is that when I send 999 to the server, I'm going to get this. I'm going to say take the last digit, so that's going to be 9, right? And make it to a string and append it. So the first digit here, the current digit to string, you can see that it's actually 9. But the next one is 10, and there's nowhere 10 to be found. So that's weird. Now what happens is that if I divide this number now by 10, I'm going to end up with a number that's going to be equal to 999.9. Once I actually say take the last digit, I'm going to take this, and it's 9.9, and when I round it, I get 10. So I say if I round the 9.9, I'm actually getting a 10. And that is why here you can see that the second digit is actually 10. One way to actually remove that is that I want to remove every single floating point. I don't care about the floating points. And in order to do that, I'm going to say x is equal to mat.trunc. So that's removing every floating point that we have. And what floating points do I want to remove from what number? From x divided by 10. I'm going to remove the floating numbers from x divided by 10. I'm going to store it in x, and then we can actually continue the flow. So let's actually see run code now, and this should get the proper result. Okay, everything is good. Let's use example test cases. I'm going to put a couple more. So 1, 0, 0, 1. You can write here your own, and let's run code. It's going to run with all of these examples that you've written. And now we're just going to send it to the server, submit, and see what are we going to get. All right, so that's pretty much it. Again, don't look at these runtimes because they're always different. It depends on the load that the current load that the server has. So you can see the first time we run 269 milliseconds, and the second time we ran very quickly. So this is not something that you should be looking at. All right, this algorithm was consisted of a space complexity that's going to be big O of n, since we are placing a number into a string, and then we're getting the digits into the string. So if the number is n large, then we're going to have an n string. And the time complexity, since we are dividing by 10 each and every round, meaning that first I have 100, then I have 10, then I have 1, it has big O of log, and we have a little 10 here, so I'm going to say log 10 of n. Okay, so that's a pretty good time complexity. The space complexity can be optimized, but for now this is actually good enough. Thank you for watching, guys, and stay tuned for the next one.